Okay, I want to show you a radio that I got on an estate sale. It's an RCA Radiola 20. This is a tuned radio frequency, a TRF radio. And it came with the cabinet and the speaker. The speaker's a model 100. And it looks to be in pretty good condition. Got the big plug on the front of it. The speaker plugs into the front of the unit. There's a headphone jack here and a speaker jack here. And all of these knobs are common with TRF radios, tuned radio frequency radios. This is a 1925 radio. And this cabinet got a power supply there that I'll talk about later. But this cabinet is in really beautiful condition. Came with a set of headphones and all of the wires for hooking up the batteries. And even came with an original manual from the 1920s. And we'll look at it in just a minute, but I want you to see inside these old tubes. And these tubes are 4-pin. A couple of them are original, but you see they're 4-pin. They have 2 big pins and 2 small pins, so that's how you know how to plug them in. And it was a battery set, and this is the battery connections that someone would use. It had all of these connections and instructions on how to hook them up. We'll talk a little bit about that when we finish up the radio. Thought you'd find this interesting here. Pull this back into the light. It's a warning to set the battery voltage to 3.8 volts, or whatever that says, 3 point something. It's hard to read. 3.25 volts. And the tubes are designed to operate from 3 to 3.3, 3 to 3.5, somewhere in there. So there were 5 tubes in this set. 4 of them are UX 199s, and one is a UX 120. If we look down inside here, you can see great big coils back in there. See them? Great big coils. And there are the tuning condensers or capacitors. And they tune, all 3 of those tune together to tune a station in. So all of these knobs have some purpose and significance. They had a little bit of a writing space here to mark station locations with a pencil. Even had a battery monitor terminal here. You could hook a meter up to this and monitor your battery voltage that you're running the filaments on, so that you don't overdrive the filaments and burn up the tubes. So this set is completely dead and silent, and so we're going to go through it and discover what needs to be done to get it running again. So we'll see what happens. Oh, here's the antenna connections. And I got a ground wire and an antenna connection. And then there's a great big cord with all the battery leads, as you can see right here. It's got all those 7 or 8 different wires that go to the battery box down below. And like I said, I have purchased an external power supply and hooked it up, and we'll see, and I've already discovered that the radio is dead. I think one tube filament, one of the tubes here, I don't remember which one of the tubes is dead. So I'm going to have to find a tube to replace that. And these tubes are extremely rare. But I have a friend who has a collection of about 70,000 tubes. So hopefully in his stash we can find something. Yeah, I said that right. 70,000, something crazy like that. So this somebody, Evansville, Indiana, I don't know what that is. But this radio came with this manual, and there's that chart again. The description of the tube sockets, ground lead and antenna leads, the tubes, and the controls. It describes the controls. Wanted to buy Atwater, Kent. I think that's what that meant. So all these instructions, and then this guy listened to different radio stations and logged them in his little log here. These are all East Coast, east of the Mississippi, and as their W stations. So you can see a lot of them here. Got a Cuba station, and WLS, I've listened to that. WGN, I've listened to that. Anyways, a lot of stations here, Cincinnati, Pittsburgh, so on and so forth. And a few more notes that the person wrote, different stations that they wrote. And he said the frequency, you know, the frequency in kilocycles, but that's not correct. Those are reference numbers on the scale here. In any case, that's pretty cool. All original stuff. 1925 Radiola 20. So let's get into it, and I'm going to pull. There are 4 screws on the bottom of this cabinet, and then this whole face right here slides out of the cabinet. Well, as luck would have it, I lost several video clips, probably on a memory card around here somewhere. It just occurred to me. No. Probably on a memory card around here somewhere. When I first introduced the radio, I showed how to tear it apart and open it up, and then started the troubleshooting process of identifying the voltages all through the schematic, and quickly discerned that a couple of interstage audio transformers were open. The windings were open. And so we're going to jump right into that place where I was able to order a couple of audio transformers that are compatible with this 96-year-old radio, and I patched those transformers into and bypassed the open transformers. Both the input and the output windings of 2 transformers were bad, and in any case, they're very, very fragile transformers and easy to wipe out with surges and those kind of things. So we're going to jump right into, I've got the chassis out of the wooden case, and the set is turned up on its side, and we're going to jump right in with putting a couple of replacement transformers in to test the unit, and then I'll come back with just a brief explanation after we get through that segment, and then we'll continue with the repair. Okay, I was able to temporarily replace the interstage transformers. Let me show you on the schematic. Now that one's kind of marked up. We've got these two audio. This is the antenna tuner antenna transformer, and then you've got an interstage RF amplifier transformer here that boosts the signal from this tube to the next stage amplifier. And then you have another transformer here, tuning transformer, and capacitors. You see all these tuning capacitors. And then we've got the detector that strips out the audio. And here are the two interstage transformers that isolate these amplifiers. We've got a headphone jack here on the low amplified signal, and a speaker connection here for the high signal. So 135 volt signal and a 90 volt signal, 90 volt power. All the filaments all of the windings in these two transformers were open. So I've replaced these two transformers, and I now have signal path all the way through, out to the speaker and out the headphone jack. However, the signal is very weak, and as you're going to hear in just a moment, I can tune a radio station. I tuned in different radio stations, and the filament voltages are correct. These voltages all read correctly throughout the circuit. There's another schematic here. They call it a continuity diagram, and it reads a little bit easier to follow the signal path. So what I'm going to do is I'm going to use my visual RL signal tracer by Heathkit, the Model T3, and I'm going to listen, starting probably in this area here, listen and see if I can follow the grid to plate signal path all the way through the radio, and we'll see if we can track where the breakdown is or where the signal loss is. I've swapped, there's 4 UX199 tubes and one UX120 tube, and I have 3 or 4 extra UX199 tubes. I've swapped them in and out of the radio. A little bit of a gain difference, very almost indiscernible difference in gain between these 4 tubes and the extras that I have. So I'm not immediately leaning on the fact that it could be a weak amplifier tube, but that's always a possibility. The filament voltage is set correctly to 3.5 or 3.8 or whatever it was recommended. I forgot now. So in any case, let's try injecting or listening to the signal as we move through here, and I'll put something on the transmitter over here, on the AM transmitter, and we'll try to tune that and see if we can hear it all the way through. Okay, I've got a signal playing, and you see the interstage transformer temporarily mounted here. What I'm going to end up doing is putting these transformers inside these shells. But let's crank it up here. And let me move the camera so I can get out of the field of view here. Okay, you can hear it playing. Okay, I've got the signal tracer right there, and we'll listen for audio along the signal path. I need to put a capacitor. Actually, I've got an RF. Let's do the RF, which is super sensitive. Let's change this to low gain. And switch this to audio. So you've got a signal all the way to the headphones. So I have this trumpet music playing on an AM transmitter, and I'm able to tune that station onto the AM radio here. Okay, so we are checking these. Let me get on camera here. We are checking these interstate transformer signal paths. I'm going to go with the grid of this first stage, tube number 4. Tube number 4, which is right here, and we're going to go on to the grid of that, which is right off of that new transformer, secondary, and it comes straight off. If you look, you can follow, it comes straight off of the tuning circuits. So we're going to go into both sides of this transformer and on the grid and the plate of pin number 4. So it might be a little bit of a trick to find that. Tube number 4. We'll see what kind of signal we have there. Right, here's the grid. Here's the plate. So we are getting amplification there. That stage is amplifying. Alright, and then let's see, tube number 4. Trying to figure out which is the final stage. Yeah, 5 UX120, which is the only tube I don't have a replacement for, UX120. So let's check pin number 5, the grid and plate. Control grid and plate. That's UX number 5, and I can't get to it. Maybe I can from here. Right, here's grid. And here's plate. Okay, so that interrupts the circuit. Let's see, what do we got with a capacitor? tube number 5. Oh, it's preamp. Okay. We're doing here is I'm following the signal through those 2 transformers that I just put in, and for some reason the transformers are passing the signal, but the signal was not amplified through the transformers. It was almost as if the transformers were attenuating the signal. So the tubes were amplifying the signal through on the audio side of the detector circuit, but all of the signal from that point to the speaker connection was not amplified adequately enough to drive the speaker. So I continued to work in this vein until I came to another discovery. Okay, we got a great amplified signal here. Super loud signal. Wonder if it's getting through to the speaker. Let's try another speaker. I got another speaker here. Okay, we've got a channel tuned in here on the secondary speaker, and it's just barely. Yeah, the second stage is not working. So the first stage is working, kind of. That's the headphone, and the second stage is just weak. And that's this other 1, 2, 3 120 UX 120 tube. Use in last audio stage. Use in last audio stage. So the UX 120 is weak, I think. We can test that theory out. Plug it in. Of course, this amplifier up above here is plug this into, yeah, plugged into second stage. That's input. That's output. Trying to see if I've got a, yeah, I do have a tube tester up here. Alright, let's just check that UX 120 tube. I don't know UX 120. I don't know if this will show up in the list. And sadly, after looking through my 3 tube tester manuals, none of those tube testers are old enough to test these 4-pin tubes. That is, they'll test 4-pin tubes, but I don't have the specs on testing them, setting up the tube testers. So I did a little research online and discovered that a lot of other guys have had the same problem with their testers and testing these tubes. So apart from just checking to see if the filament was open, I had really no way of knowing what kind of emission or efficiency the tube was going to be able to produce. Well, at this point, after a couple of days of just letting the radio sit and thinking about it and dreaming about it, I thought, well, what I could do, since I put those interstage transformers, the replacement transformers in, I wondered if maybe if I reversed the input and the output of those transformers, that because the windings there are fewer windings on the input or the output and more windings on the input, that maybe I could get a gain increase with the transformer. So that's what I did. I swapped the input and output of the transformers, both of them, and the set came alive, and just wow. So that's all I really needed to do, and so I had the transformers wired in correctly, and that made all the difference. So now we're going to pick up actually taking the replacement transformers and inserting them inside of the shells so that it looks a little more original. The interstage transformers that mount here, both are open, and so I found some transformers and installed them here, and let's test the audio.
They had better ideas than what God had.
Got our audio back. So that's great. I replaced a couple of tubes, or a tube, and then I have finally found some extras online with the adapter for the short pin tube, and these take the long pin tubes. So we're good. All of the connections work, and we're working just fine. So now we're going to install these transformers in the original cases, and you can see the epoxy or whatever they use to coat, to encase these in the metal frames has crystallized. So I'm going to dig all of this out and then set these transformers right down in here, and they will fit nicely inside these cases, and they'll be completely look almost original, and so that'll be a nice bonus, that the fact that they mount in there pretty easily. So I'll solder all these wires, like these wires here, in here, and then resolder these wires into the transformer connections. It's going to take a little bit of work to get all of this done, but I'll work on these and then show you the finished product. I'm going to have to desolder all of these connections and get rid of all of this amber glue or whatever that is. Okay, got the transformer cases clear and clean, I mean, and they're ready to now mount the little replacement transformer inside. We'll figure out the best configuration. It would look better if I did it, well, I don't know, we'll piddle with it a little bit and we'll see which fits best. With the wires all, I want it to look as original, or at least to fit and install as original as possible. So I'm going to have to experiment with the wiring a little bit. That seems to fit nicely like that, and I can put screws in here to replace the rivets. These were the rivets that I drilled out, and you can see in this one that I haven't taken apart yet, you can see the rivets in it. But so I don't know which would look best, if I did it that way and cut these tabs off. That would fit better with the wiring, because the wiring will go straight up into the cage just like that. Wires could go straight up in. That's probably the best way to go, like that. So I'll cut those tabs off, those mounting tabs. We won't need those. And but these cleaned up nicely. So let's cut the tabs off of the transformers, and then we'll go from there. Alrighty, we got the two transformers put back and they're working beautifully. So we're ready to button this set back up, put it back in its case, and we'll set it up in another location here and get it fired up. But that's the complete repair of the Radiola 20. So let's and we're monitoring the filament voltage. Remember we talked about the battery voltage for the filaments. Filaments need to be running about 3 volts, and so we put a meter here on these two terminals, and we can monitor the filament voltage. This is not an accurate gauge of power. I thought it might be, but it's usually 3.5 volts or 3 volts. Runs up here about number 6. So you have to monitor the voltage with the pins here. You can't go by this 0 to 10 volts or whatever that was supposedly intended to represent. This is the headphone jack, this is the speaker jack, this is the amplified second stage of the amplifier. That's this is the second stage, and this is the first stage for the headphone. So there's the speaker jack, there's the headphone jack, and so what we did was replace these two transformers, and I think we replaced this tube, this 199 RF tube, which the filament was open on that. So let's get it all boxed back up and we'll see how it sounds. Okay, got it all put back together, and I've got the power supply down here, and the cabinet that came with it, the original cabinet, has the original battery wires that you hooked all the batteries up, and we looked at that in the manual earlier. And I've got a few extra tubes here that I have in case I need them. So everything is here in the cabinet. Got the original Radiola Model 100 speaker. So we're going to turn the battery power on here. And I've got a meter hooked up to the meter connections here on the front of the radio. And I'm going to connect it to run at about 3.2 volts. And I've got the radio transmitter running here in the shack, playing a song. So let's see how it does with just regular AM. With a TRF radio, you've got the station selector, then you have two capacitors that tune in. This is kind of a coarse and this is kind of a fine tune. So you find a station with this, then you tune it in a little closer with the coarse, and then you bring it in a little tighter. Then there's a signal amplification knob here, which actually increases the gain of all of these circuits. And then there's the overall gain, which is right here, which increases the filament voltage on the first stage. So it's kind of a convoluted setup with a TRF, tuned radio frequency radio. That's just the way they were set up. So you would set your filament voltage to a setting here. You've got it set on 3 volts. And you can't exceed that or you'll burn the tubes out. Then you'd find a station, you'd mark it on your little white place with a pencil here, and then you tune it.
I went to the bank to make a loan, the cold cardboard. There's my heart on my heart to get home. Ain't that money?
Let's try another one. hum. That's the vibration of the tubes. It's called microphonics. The vibrating of the tubes from the base of the radio is causing the cabinet to resonate, and it makes the tubes vibrate, and then they start giving feedback, oscillating and feedback, and it'll start to hum like that. Okay, you see, well, that's a lot of fiddling with the radio, you're right, and that was pretty common with TRF sets. Some had a few more knobs here, and every stage of the tuning had to be tuned manually. Then they went to they had a belt that connected all three of the tuners together, and when you tuned one, it tuned all three coils. This is all individual. We have to tune all of these individually until you get a good signal. And that's just the nature of TRF radios. 1920. I'm 96 years old, and it's working like a brand new one. So I hope you enjoyed this video, and I've really enjoyed working on this set. It's not going to be played a whole lot up here except to demo a working TRF set, but I'm tickled that we got it working after replacing 2 interstage transformers and a tube, and we're back in business after 96 years.
You're listening to the program, what you like about it, what you don't like about it. Maybe you want less of me. You know, I can understand that.
As we mentioned earlier, briefly, the radio is designed to use all of these batteries. 3 large 45 volt B batteries, a 22.5 volt battery, and 6 dry cell batteries. And all of those batteries would fit down here in the cabinet, and they would set those batteries up in there. And you say, well, it didn't last very long. Well, the set's not designed to consume a whole lot of power over a period of time. You probably, depending on if you only listen to radio certain times of the day, you probably were fine. But in order to get this radio to play, you have to have either all of those batteries, which are no longer available, 45 volt batteries really. You've got to have a battery eliminator, and this is a universal eliminator here that a fellow built, and this is a really nice one, and it's got all the different voltages there, as you can see there. I believe we're using seven separate voltages, if I remember correctly. In any case, there is the 22 minus 22 and the minus 4.5, and there's plus 22 and or plus 45 and plus 90 and a plus 135 volts, and then there's the filament voltage over here on the end on the right. So all of these voltages are required for this radio to work. You know, and now new stuff, the power supplies are built into the radios, and you don't have a separate power supply. But 96 years ago, they used all of this battery for power. All right, well, if you stuck with me throughout the whole repair, maybe you've learned something or at least had fun watching the repair and the discussion on the Radiola 20. And as usual, thank you for watching. Thank you for your support and your subscription. Give me a thumbs up if you feel like it, or a thumbs down if you hated it. And I would appreciate any feedback that you would like to give in the comments section. I read all the comments and usually reply to everyone. If I don't, just give them a thumbs up or a heart. But in any case, don't hesitate to leave a comment if you'd like. Thanks again for watching the Vintage Tech.